Good afternoon. So we are on our fifth lab class, I think, and today's class is, as usual, going to be related to what you've been learning. So it's mostly going to be on, so the lab, it's going to be on optimizing aberrations. So you have several exercises that you need to carry out. The first few exercises relate to chromatic aberration. And in the lab class, I'm going to ask you to work on an exercise which is slightly different from what we've talked about in the previous classes. So in the classes, we looked at how you could design an achromat using a convex and a concave lens. So the optimization was carried out using two different lens types. Now we are of course still going to do that. You're going to take a convex and a concave lens, but one of the exercises that you are given for this afternoon session is how to optimize the glass type. So I just said you'll take two different glasses, one will be a low dispersive glass, one will be a higher dispersive glass, and then you work out what are the focal lengths required for these two. But OSLO also gives you the opportunity to optimize the glass type itself. So what does that mean? You will set up your optical system such that you virtually design a virtual glass, okay? So OSLO has the ability to What do I mean by a virtual glass? Now you should know that when I say a different type of glass, I'm really talking about the V number of that glass, and the V number itself is a function of different refractive indices. So a virtual glass means I'm not going to a catalog and picking out a glass type that readily exists. It will allow me to design and say, if I had a glass with these characteristics, with these parameters, then I would have minimum chromatic aberration for this system. Now, it's useful because once you have designed your virtual glass, it then allows you, there's a command which will then allow you to go and pick the actual glass which is closest to this virtual glass. Okay, so you will carry out, and there's a detailed set of instructions on how you go about doing this. The idea is not different from what you have done earlier. Earlier, if you are optimizing any parameter, you picked the operand. So say you were minimizing, so for example, if you were minimizing coma, right, you might pick as variables the shape. So the radius of curvature might have been a variable, maybe the position of the stop might have been. Now we are saying, can I design a virtual glass? So actually my glass type is going to be a variable. Okay. So the set of instructions will tell you how to set a glass type as a variable, how to run the optimization, and once you have optimized and found out which is the best glass that would give you the minimum chromatic aberration for your set of convex and concave lenses, then you'll use a command called fix, which will automatically pick from, you have to tell OSLO which glass catalog to look at, and then it will pick the glass type which is closest to that, and then you can check out the aberrations that you have with the actual real glass type. Okay, so that is one exercise that I want you to do. It comes in a separate sheet, and then you have another sheet which asks you to design a lens of a certain focal length. Now you should be able to do this really easily. But unlike last time where you just plotted the aberrations that you got for different lens shape, you're going to repeat that exercise, but you're now going to make sure that the stop is moved to the natural stop position each time. Okay, so these are basically the exercises for this afternoon's class. Make sure you do them, always referring back to the theory that we've covered over the last few weeks, because then it strengthens your understanding of aberrations and how to correct them. Okay.